Welcome to today's lesson, which is called Quadratic Inequalities. In this lesson, we're going to learn how to solve quadratic inequalities. Keep in mind that in general, when you're solving an inequality, your answer has to be an inequality too. To solve quadratic inequalities, ax squared plus bx plus c is greater than 0 graphically, we would graph the function and then from the graph determine where the parabola is graphed above the x-axis, or in other words, where f of x is greater than 0. So example 1, we're going to use this method to solve the inequality x squared minus 4x minus 12 is less than or equal to 0. So to graph a quadratic, we need to make a table of values. And we want to do that first by locating the vertex. We know the vertex is at x equals negative b over 2a. In this case, b is negative 4 and a is 1, so 4 divided by 2 is equal to 2. So we'll make a table of values. Normally we would plot the vertex and 2 points to the right and 2 points to the left of the vertex. So we'll start with that. Now I've already plugged these into my calculators. Notice that all of these y values are negative, which means we have not located the zeros. We don't know where we're crossing the x-axis, which means I have to add more points. So I'm going to add x equals 5 and x equals negative 1. When I plug those in, I get negative 7 and negative 7. I'm getting closer to 0, but I'm not there yet. So now I'll plug in a negative 2 and a 6. When I plug those in, I get 0 and 0. So at least I've finally found my zeros. Now with these y values being so large in the negative direction, I am going to have to change the scale on my graph, and I'll make the y values count by 2. So we'll join these points. And now we've drawn our parabola. Now the question is been asking us, where is this graph less than or equal to 0? Basically, where is the parabola less than or equal to 0? Well, I'm going to highlight the portion of the parabola that is less than or equal to 0 or below the x-axis. So what we need to understand is that x values between these two x-intercepts will all be solutions to this problem. So the answer to this inequality is x has got to be greater than or equal to negative 2 and less than or equal to 6. Now we did more work there than we had to. An easier way to solve quadratic inequalities of this form is to first factor the quadratic, then find the zeros and plot them on the x-axis, then check the leading coefficient a to see if the parabola opens up or opens down, then sketch a parabola with the correct direction of opening that passes through the zeros, and then from the sketch determine where the parabola is graphed above the x-axis, or where f of x is greater than 0. So we'll use this alternate method to solve example 2. Here we want to solve 2x squared is less than x plus 10, and then graph the solution set on a number line. Okay, in order for us to do this, the first thing we have to do is make sure that one side of this is equal to 0. So I'm going to move the x plus 10 to the left, and I'm going to rewrite this as 2x squared minus x minus 10 has to be less than 0. Then what I need to do is I need to solve the related equation. So I'm going to solve this by factoring, and this tells me that my zeros are at x equals 5 halves and x equals negative 2. So all I have to do is plot x equals negative 2 and x equals 5 halves, or 2.5. Then I look at my leading coefficient and I see that it's positive. That means the parabola opens up. So I'm just going to sketch a parabola that opens up that passes through these two x-intercepts. Then I want to know, when is the parabola less than 0? So the piece between the 2 points is below the x-axis. So that means that my solution is x has to be greater than negative 2 and less than 5 halves. And if I graph that on a number line, here's -2, here's 5/2. These are less than symbols, so these would be open circles, and it'd be all the points between them. Now we can also solve quadratic inequalities using our graphing calculator. So if we were going to do this for example 2, we would basically plug one side of the equation into our y1 and the other side of our equation into our y2, and then we would graph the two equations on the same axes. Basically, we're looking for when is y1 less than y2, or basically when is the parabola less than the line. Well, we can see that in this region right here, the parabola is graphed below the line, which means that our solution has to be between -2 and 5/2, which is the x-coordinates of those 2 points of intersection. Sometimes parabolas don't have any x-intercepts. In example 3, we're asked to solve x squared plus x plus 1 is greater than 0, then graph the solution set on a number line. Well, you may recognize that x squared plus x plus 1 is not factorable. So we have to try the quadratic formula. So we'll do x equals -1 plus or minus the square root of 1 squared minus 4 times 1 times 1 all over 2 times 1. Well, I don't need to do any more work because I'm seeing right here that my discriminant is a negative number, so this means that we have no x-intercepts. Okay, so I can't plot any x-intercepts, but I can still graph a parabola. Now when we look at the leading coefficient, this parabola is opening up. I don't even care where the vertex is. If I graph a parabola that's opening up, that has no x-intercepts, it could look something like that. I want to know when is that parabola greater than 0 or above the x-axis. Well, if there's no x-intercepts, the entire parabola is above the x-axis. This means that our answer is all real numbers. Now conversely, if the direction of the inequality was less than 0, you can see that none of the parabola is graphed below the x-axis. So if that was a less than symbol, our answer would be no solution. Now the way we graph all real numbers on a number line is we draw a number line and we draw a line above it. Now there's one other way that we can solve a quadratic inequality, and we can do it without graphing, and we do this by making a Sine chart. Part 1, make sure that one side of the inequality is set to 0, then factor the quadratic. 2, find the zeros. 3, plot the zeros on a number line, and then using the zeros as boundaries, divide the number line into 3 regions. 4, pick a test point in each region to plug into the factors. If the factors produce a positive number, the graph is above the x-axis. If the factors produce a negative number, the graph is below the x-axis. Example 4, solve x squared plus 8x plus 12 is less than or equal to 0 using a Sine chart. Since one side is already equal to 0, we can go ahead and factor this. So we know that the factors of 12 that add up to 8 are 6 and 2, which means that x equals -6 and x equals -2 are our zeros. We'll draw our number line. We'll put -6 here, -2 there. And then what we do is we pick test points in the region. Oh, sorry, we're going to divide this up into regions. Now a number that is greater than -2 is 0. 0 is always easy to plug in. If I take 0 and I plug it in for x into these two factors, 0 plus 6 is 6, 0 plus 2 is 2. Those are two positive numbers. When you multiply two positive numbers together, you get a positive. Now let's pick a number between -6 and -2. How about -3? -3 plus 6 gives us a positive, and -3 plus 2 gives us a negative. Well, a positive times a negative gives us a negative. And how about we try plugging in negative 10? That's a number that's less than negative 6. Negative 10 plus 6 is a negative. Negative 10 plus 2 is a negative. Two negatives multiplied together gives you a positive. So now, if we want to know when is the parabola less than or equal to 0, that's going to be the region on the number line that gave us negative values. So that means that our answer has to be between negative 6 and negative 2. That's all for now. Thanks for watching.